140 million miles away, the surface of Mars is mostly just red dust, wind, and freezing rock. But NASA's Perseverance rover has spent the last few years drilling into ancient rock, packing away core samples that might hold the first physical evidence of biological life beyond Earth. To accurately test those samples, scientists need them in pristine condition, inside Earth-based laboratories. We recently saw how well this works with the OSIRIS-REx mission, which successfully identified the chemical building blocks of RNA on asteroid Bennu. That mission proved we can mechanically capture material in deep space and drop it safely into the Utah desert. The Mars samples are perfectly sealed in titanium tubes, currently sitting in the Martian dirt. But the mission designed to go get them has stalled out. The most difficult scientific work is already done. The evidence is sitting right there on the surface. We simply lack the means to bring it home. Back on Earth, the logistics of retrieving those tubes fall under a joint NASA and European Space Agency initiative called the Mars Sample Return Program. This diagram illustrates the original mission architecture. It required a highly complex relay race. A brand new lander drops off fetch rovers, which drive the tubes to a small rocket, which blasts off the Martian surface to meet a separate orbiter, which finally flies the rocks back to Earth. Initially, NASA estimated they could pull off this sequence by 2033, capping the total cost at $7 billion. As engineers started building out the hardware, the sheer difficulty of coordinating multiple custom vehicles piled up. The projected cost jumped to $11 billion, and the timeline slipped all the way to 2040. That massive budget bloat triggered a sharp reaction. Congress passed a budget that zeroed out support for the current mission architecture, paralyzing the program. The Mars Sample Return project collapsed under its own weight. The logistical complexity of the design priced it entirely out of existence. While the budget debates stall out on Earth, the physical hardware at Mars is actively degrading. Everything Perseverance does is routed through the Mars Relay Network. It's a small group of satellites orbiting the planet, and without them, Earth has no way to communicate with the rovers on the surface. That network took a critical hit. In late 2025, the MAVEN orbiter began spinning uncontrollably, draining its batteries until NASA officially declared the spacecraft dead. The surviving satellites in that relay network are between 10 and 25 years old. They are operating on borrowed time. The United States is losing the funding to build the return vehicles at the exact same time it is losing the orbital infrastructure required to guide them. When a leading space agency hits pause on a major initiative, it leaves a geopolitical vacuum for rival nations to fill. China is actively developing its Tianwen-3 sample return mission. Their program remains on schedule, posing a direct threat to American leadership in returning the first Mars samples. But there is a proposed alternative to both international rivals and NASA's stalled bureaucracy, and it comes from the commercial space industry. SpaceX's Starship is designed with a massive 100-ton payload capacity. Instead of relying on a fragile chain of small fetch rovers and specialized mini-rockets, a vehicle that size could theoretically fly a complete return system in a single trip. This commercial approach offers a consolidated design, aiming to bypass the specific logistical bottlenecks that inflated NASA's budget to $11 billion. To get these rocks home, the logistics may have to shift away from traditional government programs and toward the commercial space sector. The priceless Martian rocks are already waiting on the dirt. Today, institutional bureaucracy is the final barrier between humanity and the definitive discovery of alien life.